So what do you have to find first? Well, first of all, they want you to... What kind of differentiation are you going to use? You're going to use implicit differentiation. So you're going to have 2x plus what? 2y, y prime equals what? 0. So you know that x plus 2y, y prime is equal to... Oh, wait, the whole thing is get rid of that too. What should I isolate? I mean, you feel better when you do this. So y prime is equal to negative x over. So that's the first derivative. What should we plug in next? Not plug in. What should we find next? Yeah, y double prime. What rule am I going to have to use, Neil? What rule am I going to have to use? Quotient rule. Good job for listening to your friend. So low d high minus high. What's the derivative of low? Low d high minus... Oh, you're telling me already? Okay. All over what? Over what? So you end up with negative y plus y prime times x. Correct? All over? Yeah, now, what'd you say there, Biggie? Something important there. Yeah, you know that this right here can get plugged in right there. So you know that, just to finish this if you want to, y double prime is going to be equal to negative y plus negative x over y times x all over. And they're asking for y double prime at the point what? 4 comma 3. Yeah, it's okay, it's okay. Equals, it's going to be negative 3 plus negative 3 over 4 times... Oh, 4 over 3, thank you. Negative 4 over 3 times 4 all over 9. So you're going to end up with negative 3 minus 16 over 3 over... What should I multiply everything by? I'm going to multiply everything by 3. Sound good? So I'm going to get negative 9 minus 16 all over 27. I'm multiplying by 3. So what do I end up with? Negative 9 minus 27, minus 16 is negative over. Is that one of the answers? Negative 20. So is it negative? Yep, there it is, A, right there. Good job. Does that kind of make sense? It's asking where's the function what? It's where's the function increasing. Exactly. So, Carter, please, really got to stop the chatting. What do you have to look at if you're going to try to figure out where a function is increasing? The first derivative. You're looking at the first derivative. For what values of x for which the function is? Oh, that's what you meant. Okay. So what's f prime of x going to be? What do we have to use? Or what should we use? We should use the product. That's what I would do. So the derivative of the first times the second plus the first times the... you have to put that negative out front, right? So then we're looking at where this is increasing. So really, what do we need to find first? Where the first derivative is 0. So we're looking at 2x e to the negative x plus, or minus, right? Minus x cubed minus 3 times e to the negative x is equal to, what can I factor out? E to the negative x times 2x minus x squared minus 3 equals 0. So you want e to the negative x times negative x squared plus 2x plus 3. Do you see that, everybody? Is that correct? Yes. Now, what I like to do is I would factor out the negative. Yeah. This is what I would do. Make it x minus 2x minus 3. It's just a little bit easier to factor. Can e to the negative x ever be 0? No. Negative e to the negative x can never equal 0. So we're really looking at this equals, so x minus 3, x plus 1 equals, so x is equal to 3 or... So now what do you have to test? Regions, yeah. Negative 1, 3. We have our x values and our f prime values. We know what's the derivative at those values. What's the derivative at those values? 0. How many regions do we have to test? 3. So we know what the derivative is. What's the simplified derivative here? This was the nicest simplified derivative right here. It's going to be a little tricky to do this. This is a non-calculator section, right? So we're looking at negative e to the negative x times x squared minus 2x. Actually, factored form, what's that going to be? X minus 3x plus 1, yep. So we're looking at the sign of this. What's the easiest thing to plug in? Plug in 0, what do you get? Negative 1. You get... Oh, what did I program you to make, hopefully? So you have negative e to the negative x, x minus 3, x plus 1, and the product. Do you remember this? Let's plug in 0. What do we get? -1. You get negative, right? Negative and positive. So what does it come out to be? Positive. Let's plug in, so we know that this is positive. Let's plug in -2. It's going to be negative, right? Because e to any power is what? E to any power is what, Carter? Positive. So negative e to any power is going to be negative. Negative e to any power, right? Yeah. -2, it's going to be negative and negative. So what's it going to be? Negative. And then we test, I don't know, 4. It's going to be negative, positive, positive is negative. So this question is asking, where is it increasing? So where is it increasing? -1, 2, 3. What's another way they could have written that? -1 to 3. Either one. They're the same. So which answer is it? D, right there. Nicole, you're happy with that answer? Yeah. Okay. Questions I'm asking, for what value of t will the velocity of the particle be 0? So what do we just need to solve? 1/2 t squared minus cosine t minus 1 is equal to? What are you going to have to use to solve that? You're going to have to use your calculator. Do you know how to use your calculator to solve that? Is it equal to? 3x squared plus 2 sine x. So what's the second derivative going to be equal to? Plus 2 cosine x. So what are you interested in finding out? Where that's positive, where it changes from positive to negative. But what do you have in front of you? Calculator, right? So what? Can someone tell me what the function is again? It is, read it to me.
X cubed plus...
No, what's the second derivative function?
6x.
6x, yep.
Plus cosine.
Plus 12, yeah. Plus 2 cosine what? 2 cosine x. And is there any domain restriction on this? There is no domain restriction on this. So let's zoom. Trig is a good place to start. So let's see what this function looks like. Wow, it goes up. Let's zoom out a little bit just to make sure. Let's zoom out. We just zoomed out. This function is going, whoa. So is there, what are we searching for? Where this goes from -2? So what should we calc here? Second calc what? 0. What is it asking me for right now? Left bound, you press enter. Right bound, you go to the right of where it is, press enter, and then a guess, enter. And look what it tells us. That's the 0 of the second derivative right there. That's the 0 of the second derivative. The 0 of the second derivative is right here, and it has an x value of -1.89. Is that one of the answers? Yep. -1.89 right there. If you have your calculator, use it. If you have your calculator, use it. If you don't use your calculator, you're going to lose the derivative. It's the limit definition of derivative, and it tells us the derivative of f at 2 is 5. Is 2 true? What did we just find? We just found the derivative. So which one's definitely true? It's definitely differentiable, right? And it says f is continuous at x equals 2. Do we know it's continuous there? Differentiability implies continuity, but what about the reverse? Does continuity imply differentiability? Because always remember this. See that? Is that continuous? Yes, it's continuous. Is it differentiable there? No, but differentiability does imply continuity. So it's differentiable there, so it must be continuous there. Do we know anything about the derivative of f? The derivative of f is continuous at x equals 2. Do we have any idea if the derivative of f is continuous there?